So, what's everybody want to do first? We'll do problem one. The nice thing is, when you see, did it say it here? Oh yeah, it does. Okay, so in this bubble, it says a fraction bar means division and a grouping symbol. Okay, so what's nice about the fraction bar is you can actually like kind of group the top versus the bottom, or the numerator versus the denominator, and you can kind of do what's there accordingly, okay, separately. It doesn't hurt anything, okay? So for this question, I would say the 9 plus 3 would be the 12. Okay, that'll be the top part. Okay, let's see if I follow along here. I'll highlight this. And then what's next? What's BEDMAS tell us to do in this instance? It comes for, yeah, Polly? Division. Division. Let's do the division. 12 by 4 should be 3 plus the 7. Now you can just straight up add it out and we're good. 10. Okay. As easy as these questions seem, sometimes they can get quite tricky because they've been written in a way. I don't know if there are any on here like this, but I've seen some in like any of the stuff I've given out in grade 10. They've been written in a way to purposely trick you. And they can get quite tricky. You gotta pay attention to the order in which you do things. Okay? So, let's go down to B here. What are we going to do here? You always think back to your BEDMAS, right? So you're gonna think, yeah.
9 minus 7.
Okay, let's do the 9 minus 7. Okay. So we're gonna rewrite this. 9 minus 7 is gonna turn into the 2 cubed plus 4. Okay, now I do see this from time to time too. People want to do this and multiply it in, and then they try to do this. Now your answer is gigantic, right? Can't do that, right? And then hopefully at some point, if that was a word problem, you got some absolutely absurd answer, you would go back and catch that, okay? But BEDMAS says do the brackets first, then deal with the exponents. Okay, do we know what an exponent is? Yes, Ollie?
The little 3 above.
And it's a little 3. Okay, so an exponent would be like this 3 here. Would be an example of an exponent. Do we know what it means? We did talk about like this. I think we talked. Oh no, I wasn't in this class. Oh yeah.
2 to the power of 3.
Okay, so it literally means 2 to the power of 3, which may or may not mean something to some of you. Yes?
Repeat multiplication.
Yeah, it's basically, that's a good way of putting it. It's a repeat multiplication. Okay? So like an exponent, that's a good, I've never heard that before. Let's write that down. Exponent. $109. Okay, well, so what does that mean here? Well, if some of you are struggling with this concept of what that actually means, again, this could be like, could be a calculator exercise sometimes, depending on how big the exponent. I don't think anybody would expect you to know the answer to like 2 to the power of 55. That's a calculator exercise. I don't know when you would encounter that, but sometimes there's instances where you're just not expected to know that. But something like this one is not too bad. So what this definition could mean would be repeat multiplication. In case you didn't have a calculator, this is what it would mean. It means that there are 3 2's attached with multiplication. Okay, so it looks something like this. 2 times 2 times 2, right? Which is 8. Okay, this is a pretty good. You use this. This ain't going away. In fact, you spend an entire probably 2 weeks in grade 11 math just doing exponents again. Oh, it might be longer, 3 weeks. It's an entire unit just dedicated to exponents and exponent laws and like solving exponential questions. Like it's probably 3 weeks of content. Okay, so knowing this, that's a good little trick. Okay, so now we know what 2 cubed is. That's going to be 5 times 8 plus 4. All right, you're thinking this turned into the 8 in case you're wondering. Okay, what's 5 times 8? Okay, are you gonna add the 4 to, I don't know what, see, sometimes like I take for granted sometimes because I've done enough like questions and things. There's really like, what could you possibly add this 4 to in its current state? Like nothing, right? It's not, you're not gonna add the 4 inside the bracket because it's not inside the bracket. And that's why, like yesterday when I was saying some things about like the brackets acting as like a wall or a barrier, that's kind of what they are, right? They're like keeping things separate from other things so that you know you're not adding that 4 to the 8, right? So sometimes you'll catch when we go through the course, if we do some expansion or something, like we say get rid of the brackets. That like breaks down like walls so that you can like ultimately collect like terms. I don't know if that means anything to you yet, but anyway. So we can do 5 times 8, be 40. Then we're going to add the 4 to get the 44. Okay, everybody happy with that? Okay, the next one, why don't we just rewrite the next one? Remember what I said, you're going to start moving away from these like elementary school kind of symbols for multiplication division, right? Let's rewrite this question. Okay, we're going to go 4 times -3 divided by -2. And then we're going to do what? Be careful with this on the end. You're going to subtract off a negative. So 2 negatives make a, yes, a positive. Okay, so we're going to go this and then add a 5 at the end. Okay. Now, what comes first? Does it matter? Does it matter? I'm going to show you 2 things here and see what happens. Okay. This is an example. Let's see. I'm going to show you 2 ways. Some of you are going to do this in one of these 2 ways, I think. I think, number 1, everybody multiplying the 4 times 3. Is that what people are jumping to? I think that's pretty typical. You can do the 4 times -3, which would be -12, and then you can divide by -2 and then add the 5. The second way, you could divide the negative, or the 4 by -2. What is 4 divided by -2? Sorry, yeah, it is negative. Yeah. Okay, so I've written this question 2 different ways here. Everybody see what I did here? What is 4 divided by -2? It would be -2 times -3 plus 5. We would get 6 plus 5. We'd get 11. What do we do over here in the black? Well, -12 divided by a -2. 6 plus 5 is 11. All right? Same answer, 2 different ways. Reason why we show you 2 different, well, we show you multiple ways to do the same thing all the time because sometimes one way is easier in one application versus the other. Right? Okay, what's next? You want to do? Does anybody have any questions for that one? We're okay. Go down to D. What's the rule? Are we going to multiply these things together? No, I would do the brackets first. Okay, do what's inside those brackets. So 6 take away 9, be -3. And what's -3 plus 7? 4. Okay, if you're ever stuck too in the middle of a test and we say no calculator, you know, if you're stuck on something that says like -3 and add 7, I don't know if you are or not, something this is up here for a reason. You're standing at -3 and it tells you to go to the right, positive numbers go right, negative numbers go left. So if you're standing at -3 and you go 7 to the right, that's what that says. We just count 1, 2, 3, 4, 5, 6, 7. It might not 4. Okay, so if you're ever in a test and you're mixing negatives around and you're like, I don't know what's what, you don't have to think of them as negative and positive or like addition subtraction. You can think of them as like negative starting points and then move from your starting point around. Okay, that's also an option. Okay, and then now you could go -3 times 4, be -12. Okay? 2 times, what are we going to do here? Ooh, good question. Mr. Poling knows what he's doing. Good question. He's got all these points. You'll see, like, he's done a good job at identifying all the key issues that end up arising. Okay? So, for instance, we're going to have a good conversation here in a sec. We're going to do the work inside the brackets as per usual, right? 2 times, what's 5 minus 8 would be negative 3 squared plus 15. Okay? What did we just say? So let me ask you a question. If you know the answer, don't yell the answer. This is a funny thing because I just saw kids write a grade 10 exam writing down the wrong answer. No matter how many times I say this, they get it wrong. What is negative 3 squared? Now, this is why I think maybe we're pushing everybody. Well, we should do more of this. Push everybody towards not using the calculator, because what will happen is, here's what kids will type in the calculator. And this is one of the reasons why it comes up wrong. They will do this. Does anybody have a calculator handy and they'll type that in and tell me what the answer is? This is classic. This is a classic error. That's actually not wrong in its current state. Can you tell me why that's not wrong in its present state? Yes?
Because you multiply 3 by 3, and then you would just have a negative.
Okay, so in its present state, this isn't what we have on our page, but this is what ends up this is what kids end up typing in their calculator. And like, I'll get into that conversation in a sec. But this is what it means, okay? It's 3 squared with a negative on it. That's why that's not wrong the way that it's written. It's 3 squared with a negative on it. What would be wrong, and this is why kids get it wrong all the time, right? You need to put it in brackets. That now tells your calculator that it's negative 3 times negative 3. This idea of what did you use? What was the wording you used? Repeat multiplication. It's a good way to describe it. I hadn't heard that before. Okay, so that physically means it's negative 3 times negative 3. Right? What do 2 negatives make? A positive. This is the frustrating part, right? No matter how many times we say this, it's an issue that rises right into grade 11, I'm sure, because I've seen it. No matter how many times we say it, when you multiply 2 negatives together, you get a positive. You still see this on people's tests. In this particular instance, they'll type it in their calculator. They'll go negative 3 squared, and then they'll get 2 times negative 9 plus 15, and they get the wrong answer. Okay, no matter how many times we say it. My hope is, and hopefully I think some of the hope, or maybe like now that I'm teaching a grade 9 course at its base level, we're trying to push this idea of not using the calculator or relying on it, because if you don't use it properly, you'll get the wrong answer. If you just think about it, use your brains. You just look at that and think, I know what happens when I multiply 2 negative numbers together. They come out to be positive, right? Your calculator doesn't know unless you tell it, right? And unless you put the brackets in, you're going to get the wrong answer. Okay, so you got to be careful, all right? So I mean, Mr. Poling has thought of like he's got a good lining of questions. Oh, I don't even want to do this. Okay, so what are we going to get here? We're going to get 2 times negative 3 squared is going to be 9 plus 15. 2 times 9 will be 18. Add on the 15. What are we going to get? Get 33. Are we happy? Okay, please. I know again, not the most difficult lesson, but there are little tricks in here that will get you, and they will give you wrong answers. Okay, can't get complacent with things. You got to be careful and be very like rigid in what's going on. Even something like BEDMAS, you go out of the wrong order in BEDMAS, you're gonna get the wrong answer. Which is why we're doing this. We're just trying to like emphasize some like very important base skills moving forward, so that we don't. You're gonna have to know how to multiply fractions. We're gonna do that. We don't want to see kids making this mistake with this -9 thing. That's a deter. That's like a. It's a deterrent from the standpoint that you get a wrong answer, now you get discouraged and you don't know why you got it because it seems like you've got it all right. You've just done something silly, right? And then kids get frustrated with math, they don't like math, and then they spend way too much time doing one question that should have been done in 2 minutes. You know what I mean? Okay. So, let's do the last one. I'll run through a couple of these and then I'll let you guys do some work, okay? Remember we said this fraction bar is kind of your friend because it breaks the question up into 2 pieces, right? We can do all the stuff in the top according to BEDMAS, and we can do the stuff in the bottom according to BEDMAS, okay? So what do you want to do first? Let's do, what comes first? Let's do the top. What comes first? What are you going to do first in the top? Yes, Colson?
We're gonna multiply the 3 and 2.
Okay, let's do that. So we're going to have -4, 3 times 2. Well, then it's also -3 times 2, I suppose. So it's going to be -6. Okay, that's this right here. I like doing this sometimes so kids can see. This will become more useful as we go through like more complicated stuff. So if you get in the habit of like looking, what I'll try to do all the time in case you have any question, you're like, where did that -6 come from? It doesn't have to be this question, but something more complicated moving down the road. What I'll do is I'll try to highlight the work and then show you, I'll highlight the answer too so you can see where stuff has come from. Okay, I'll try to keep doing that. Okay, and then 20 divided by -4 should be -5, right? Now we can do the work on the top, right? We get -10 divided by -5. Okay, that should be 2. Okay, not much different than what I showed you this morning already. Or not this morning, at the beginning of this. Okay? We're going to try and evaluate these expressions. It gives you the conditions. Sometimes it's going to use S. Sometimes it'll use T. Sometimes it'll use both. Right? Could use it in whatever combination you want. It could be multiple S's. There could be, I don't know. You could multiply by an S in the top and then divide by an S in the bottom. There's all sorts of combinations. All it means is, again, there's that word evaluate. Just give me an answer, a numerical answer. Here are your conditions. Take those conditions and plug them in. And then just do the math like you normally would. Okay, but you got to be careful with the BEDMAS stuff. Okay, not a free-for-all. Okay, so this one here, not too bad because there's just one thing going on. You take -7. What did we say S was equal to? -2. So then you just do the math on it. -7 times -2. There you go. Okay. And for this one, we're going to go 8 take away 5t. T we know as being 3. So let's do that. 8 take away 5 times -3. Can you do 8 take away 5 and then multiply the answer by -3? Yes? Oh, just 3. Sorry. Thank you. Are you allowed to do that? No, you can't do that. That's silliness. You can't do that. Right? Because BEDMAS tells you got to do the multiplication before the addition subtraction. Right? So that's no good. Let's not do that. We're going to go 8 take away 15. Right? Because 5 times 3 is 15. Okay? What does 8 take away 15? That's it. Yeah, if you ever struggle with that, not the easiest one, I don't think. If you ever struggle with that, you should stand at 8 and count 15 left. You should land on -7. Okay, that's why that's up there. It's free to use. Free real estate. Nothing? That was bigger a few years ago. Alright. Alright, let's do S. Okay, we'll do C. Sorry. So for this one, we go negative times negative 2 squared plus 3 times negative 2 minus 5. We all right? Negative 2 squared is? Did you touch this negative yet? You haven't touched that negative yet, so leave that alone. Like, carry it down. And what's negative 2 squared? It's 4. Negative 2 times negative 2. Okay. That'll be 4. 3 times negative 2 will be negative 6 minus 5. So you get negative 4, take away 6, take away 5. Negative 4, take away 6. That's going to be negative 10. Take away another 5. We're going to be at negative 15. Did I do that too fast? I can't tell. I honestly can't tell. I haven't figured you guys out yet. It's 100% okay if that's going too fast. If I remember going too fast, you just say something. Doesn't matter. Okay, we'll slow down. Okay. 2 more and then I'll let you guys go. Okay. 4 times S is negative 2 squared minus 2 times negative 2 times 3 minus 3. Okay, I'll highlight all the T's so you can see where they went. And I'll highlight all the blues. This is where things like it can get, if you're going to make a mistake, it could be in here substituting things in places. Okay, now you just do the math on everything. Exponents, then any, well, brackets, then any exponents. We don't have any brackets, so, or any work to be done inside of any brackets. So then we can do the exponents, then we can do any division or multiplication, and then we'll do the addition subtraction at the end, okay? Yes, Ollie? Yeah, bud. Okay, so we'll deal with the exponents. We're gonna get 4, we're not touching the 4 yet, because we're dealing with the exponent. So it's 4 times negative 2 squared will be 4. Take away, well, we could do some work over here if you want. Take away 2 times negative 2 times 3. Negative 4 times 3. It'd be negative 12. Take away 3. Okay, so we're going to get 16. 2 negatives make a positive. That's good. Okay, so plus 12. Take away 3. Okay, so we can get 16. 16 plus 9. Okay, we'll go one more, and then I'll let you guys go. Not for break or anything, but just to do some work. Okay. So, one more. Negative 6 times S. Negative 2 times T is 3. 6. Negative 6 times negative 2. That'll be the first little bit. We could do positive 12, sorry. 12 times 3, which will equal 12 times 3 will be 36. 36. Okay. Okay. So what you want to do, well, I'll just guide you through this here. So, okay, so for your questions here, the last little bit, what I want you to do, have you ever seen a table of values? We're going to do a little bit of this in our next, well, in any of the units. This is a common, doesn't matter what the graph looks like. This is just a graph. It's going to produce a picture on the grid. Okay. Do you guys remember plotting points? Have you ever plotted points before on a grid? Have we ever done that? Yes? So if you had like a coordinate grid like x, y, here are your x's, here, these would be what you would call y's, or we'll call these outputs. Y is always kind of an output, and x is an input. Do you know why we call them that? So I'm going to take values of x. Here, I'll do it in a highlighter. I'm going to take values of x, and I'm going to input them into my equation, and they're going to spit out y values. Those are what we call outputs. Okay? All these numbers will be outputs. And then you'll have a bunch of points. You'll have like -2 and some y value, and you'll go plot it. Whatever it might be. It might be, I don't know. Well, you'll find out. 5 maybe, right? And then what you're going to end up getting is a whole bunch of points as you do this. And the graph might look something, I'm just guessing, because I know what I'm doing somewhat sometimes. I'm thinking the graph might do something like this. When you guys actually go to plot these, if you wanted to do that, it would look something like that for this particular graph. Okay? This will always, you can always create pictures or graphs from a table of values, and that's what this is going to do for you. Okay? You're going to take the input, whatever the inputs are, all of them, and you're going to input them all individually into the equation and get new outputs in these boxes. And they're going to create points. You can plot those points on the grid, and it'll give you a nice graph. Okay? I know there's not a grid there, but I'm just showing you what ends up happening. Okay? Does anybody have any questions? What's going on? Okay, you're going to take each of those x values and plug them into the equation, and then get some numbers, new numbers, as we call outputs. And then you guys can have a go with the rest of this. Okay? That sound good? You can take some time now before break.